Okay, so today we are going to look at this module 8. So this module 8 is about a program control. Okay, so you're going to learn what is the instruction, okay, in order to control the programs. Okay, previously what happened is when you write a program, okay, you just write a program that execute from top to bottoms. Okay, but now, okay, we're going to change the program flow. Okay, instead of from from top to bottom. Okay, now you're going to have a branch. Okay, which is you okay, from here it will run back to the top, and then maybe it will go to down here. Okay, so this is how we're going to control the program flow. Okay, so the first one here, okay, now we're going to look at the branch instructions. What are instructions that is you're going to learn, okay, every time you're going to do a branch. Okay, so this is the overview of the branch. Okay, as I can see here, the branch instructions are used to change the flow execution by altering the program counter. Okay, by alter the program counter, you can change the flow of the program execute. Okay, so this instruction allowed for conditional and unconditional jumps to a different part of program, making that crucial for implementing control structure. Okay, bear in mind that, okay, for the branch instruction, we have two type of branch instructions. Okay, the first one, we call it as a conditional branch lah. Okay, which is the branch only taken, okay, when a certain condition is met. Okay, means that if you have a condition and then the condition is true, or the condition is met, then after that the branch will be taken. Okay, the second one here is an unconditional branch. The unconditional branch is means that, okay, you have an instruction that force your program to branch to a certain location. Okay, we don't need to look at the condition, whether the condition is met or not. Okay, so for the unconditional branch means that, okay, no need to look at the condition. Okay, the condition of the instructions lah, whether the condition is true or the condition is false. Okay, how to look at these conditions? Okay, to look at these conditions, we're going to look at the flags. Okay, we already learned about the flags, which is the flag is inside of the APSR. Okay, we have 4 flags inside of the APSR, which is the Z flags, N flags, C flag, and V flags. So these flags here will be need to take into consideration lah. Okay, every time you're going to do a condition branch. Okay, whether the flag is set or clear, then after that the branch will be taken. Okay, so there are 3 control structures that you're going to learn. Okay, the first one is a loops lah. Okay, the loops is you're going to create what we call here to do a to create a loop, okay, by using the condition branch. Okay, then we have the conditional statements, and last but not least is a function calls. So this is the control structure that you're going to learn in this class, okay, by using the branch instructions. And there are 5 types of branch instruction in ARM programming. Okay, the first one is a B. Okay, which is B is for the branch lah. The branch with unconditional branch. So this one is unconditional. And then we have the BL, okay, the branch with links. So this branch with link is used whenever you're going to call a function. Okay. Then we have the BX, the branch and exchange, BLX, branch with a link and exchange, and last but not least is a conditional branching instructions. Okay, so which as we look at these names here, okay, so the branch will only be taken when the conditional, okay, is met. Okay, the first instruction that we're going to look at here is a B instructions. Okay, the B instructions stand for a branch. Okay, and this B instruction perform unconditional jump. Okay. So unconditional jump means that you don't need to look at the flags. Okay, you just force the program counter to directly go to that location. Okay, we don't need to look at the flags. Okay, so how to jump? Okay, by looking at this specific label or memory address. Okay, we can use the label or we can use a memory address to branch from one location to another locations. So in this branch instruction, okay, it modifies the program counter to point to the target instructions. Okay, and this is the syntax. B followed by a label. Or sometimes this label here, you can change it with a memory address. But most of the time, we're using a label lah. Okay, so to make our life easier. Okay, and regarding the operations, okay, so this is what happen lah every time the branch instruction is execute, which is the PC equal to label. Label is the memory address. Okay, means that every time you go to B label, okay, so the label, the memory address of that label will be put or will be loaded into the program counter. Okay, so let's look at this figures here. Okay, so we assume that the function 0D is your main program lah. Okay, you have a main program. Okay, you run a main program, and then in the middle of main program, you see you have this instruction P function 1. So what happened here is the program counter, okay, will have this function 1 memory address. And then after that, the CPU go to the function 1 and execute all of the instruction below of the function 1. So this one here, it is a conditional jump. Okay, no need to look at the N, B, C, or Z flags. Okay, let's look at these examples here. Okay, the examples from this program. Okay, we have the B loop underscore start. Okay, which we can see loop underscore start is the label. So what happened here? Okay, so program counter, okay, will have the memory pointed by loop underscore start. Okay, whatever the memory address will be loaded to your program counter. And then after that, your CPU will directly jump to this location, which is loop underscore start. And then start, okay, do the code under this location. Okay, loop underscore start locations. Okay, so this is what the branch instructions do, the B instruction do. Okay, moving on to the next slide. Okay, we have the BL instructions. Okay, the BL is stand for branch with a link. Okay, and this BL instruction branch to a specific address or label and save the return address in the link register. Okay, the difference between B and BL, the B instruction go to the specific address or go to that label, so the location pointed by the label, without, okay, save the return address. Okay, but for the BL instructions, so what happened here is it still go to the location pointed by the label. Okay, and at the same time, okay, it will save. Okay, it will save the return address. Okay, what is the return address? Okay, the address of the next instruction. Okay, in the link register. Okay, in the LR. Okay, you need to remember back in our in ARM register. Okay, we have total of 15 register. Okay, 13 is used as the what we call here general purpose register. Then we have the link register. Okay, program counter and stack pointer. Okay, so here you can see this is a link register. The link register will hold the return address. Okay, every time this BL instruction is executed. Okay, so where you going to use this BL instructions? Okay, the BL instruction is commonly used whenever you're going to call a certain functions. Okay, every time you call a certain functions, then you need to use a BL. Okay, the branch with a links. Okay, looking on the syntax. Okay, the syntax is BL followed by the label. Okay, and then for the operation, okay, so this is what happened lah. Okay, first the LR. Okay, the LR will, okay, inside of the LR, return address will be saved. Okay, so that's why you can see by looking at the formula here is PC plus 4, means that the LR will get the address of the next instruction. Okay, right after the BL instruction is executed. Okay, and then after that, after the CPU save the return address inside of the LR, then after that it will branch to the target address. Okay, which is PC equal to label. Okay, contoh lah. Okay, so this is your main program. Okay, you are execute the main program, and then suddenly, okay, the BL instruction is executed. So when this BL instruction is executed, so what happened here is the LR, okay, will save the return address of the next instruction. Contoh lah, I give you a contoh. The next instruction is this instruction, right after the BL instructions. Okay, and we assume that this BL instruction is located at address 1000, okay, inside of your program memory. Meanwhile, okay, the MOV R0RY, which is the instruction after the BL instruction, is located at 1004. Okay, now, so what happened here is your program counter is pointed to address 1000. So this is where your program counter, your PC pointed to, okay, which is you're going to execute this instruction BL function 1. So before the program counter go to the function 1, okay, I assume lah, okay, we assume that the function 1, the address inside of the program memory for the function 1 is 2000 lah. Okay, we just say it as a 2000 for examples. Okay, so what happened here is, okay, first CPU will save the return address inside of the LR of the next instruction. What is the return address of the next instruction? This address. Okay, so inside of the LR, we'll get 1004. And then after that, your program counter will equal to 2000. Okay, why 2000? Because the 2000 is for function 1. Okay, looking at this function 1, where the function 1 is actually located at 2000. So that's why your program counter now pointed to 2000. Then after that, it will go to here. Okay, jump to this function 1. Okay, do whatever instruction inside here. Then after that, after it going to return from the function, so it will go back, okay, to this address 1004. Okay, compared to the branch, okay, the B instruction, after it branch, it will never go back to the location right after the B instruction is executed. But for the BL, okay, it will go back to the instruction after the BL instruction is executed. Okay, that's the difference lah between the B instruction and BL instructions. Okay, so contoh. We got a contoh here. Okay, BL function. Okay, so what happened here? The program counter going to branch to this location. Okay, but before it branch to the location, the function location, the LR will have the address of these instructions. Okay, the address of this instruction here, which is PC plus 4 lah, okay, will be stored inside of the LR. Then after that, okay, the CPU jump to the function and do the instruction inside of the function call here. Okay, so this is what the BL instruction do. Okay, moving on to the next slide. Okay, we have the BX instruction. Okay, the BX instructions stand for branch and exchange. Okay, it will branch and then at the same time it will exchange. Exchange what? Exchange the instruction. Either the instruction is run in the thumb state or arm state. Okay, so that is the difference lah. Okay, between the BX and B. Okay, so the BX instructions, okay, branch to the address, okay, store in a register. Okay, so this one here, we're not using the label, but the address must be stored inside a register. Previously, we using a label to branch to that location. But if you're going to use a BX, you need to store the address inside of the register. Okay, after it branch to address stored in a register, then it will switch the instruction state, okay, depending on the least significant bit of the target address. Okay, the least significant bit of the target address means that bit 0 lah. Okay, so let's say lah, this is your RN. Okay, so this is bit 0. Okay, when bit 0 inside of this address here is 1, means that it will run under the thumb state. Okay, it will change lah. Okay, run in the thumb state. And if 0, then it will run in the arm state. Okay, so this is the syntax. BXRN. Okay, we use the register lah. Okay, to hold what we call here the address. Okay, to the location that you're going to branch. And this is the operations lah. Okay, so the operation, if you can see from this operations here, if Rn zeros equal to 1, okay, which is if bit 1, okay, sorry, if bit 0 here equal to 1, so it will switch to a thumb state. Okay, but if bit 0 equal to 0, it will stay in the arm state. Then after that, PC equal to Rn. Means that at this moment, okay, the branch happens. Okay, which is go to the location pointed by Rn. Okay, contoh. We look at this contoh here. Okay, LDR R0 equal to 80000001. Okay, so what happened? Okay, you're going to put this address to your R0. Okay, put the address to R0. So now R0 will have this value. Okay, then after that, BX R0. So what happened? Okay, before we branch to the location pointed by R0, which is at address 800001. So what happened here is, okay, we're going to check lah at this bit here. Okay, whether it's a bit 0 or bit 1 at bit 0. Okay, at the LSB. Okay, so since this value is 1, okay, if you change it to binary number, it will become 001, and this is the bit 0 lah. Okay, when you look at this bit 0, it have a value 1. So what happened here is, now, okay, this program will switch to a thumb state. Okay, it will run under the thumb state. Okay, then after that, it will go branch to this location. Okay, pointed by R0. Okay, that is for the BX instruction. Okay, then we have the BLX instruction. Okay, the BLX instructions stand for the branch with link and exchange. Okay, so what happened inside of the BLX? Okay, the instructions, okay, branch to the address. Okay, it will branch to address stored in the RD. Okay, similar to the BX instruction. And then it will switch the state depending on the LSB of the address. Okay, then what happened? There is an additional things lah. Okay, you need to add here. Plus, okay, the return address will be stored in link register. Okay, so there are three things. Okay, first, save the return address in the link register, and then switch the state, okay, according to the least significant bit, whether it's a 0 or 1. Okay, if 1, switch to the thumb state. If 0, it will stay in the arm state. And the third one, it will branch to the address stored in the RD. Okay, so that is the 4 instruction that we already learned. Okay, the instruction that we commonly use lah is the B instruction and then a BL instruction. Okay, and the fifth one, okay, this is the third commonly used instruction. Okay, we'll call it as a BCC, or branch with condition. Okay, so the branch with a condition instruction perform a conditional jump. Okay, so this one here, okay, we're going to look at the condition. If the condition is met, then the jump happen. If not, okay, the CPU will do the next instructions. Okay, so the conditional jump to the specified label or a memory address whenever the condition is met. Okay, and this is the syntax. Okay, by looking at the syntax, you can see here B followed by the condition. Okay, the condition they're going to check. and the label. The label is the address lah. Okay, we just put the label to jump to a specific locations. And regarding the operation, okay, if you can see here, if the condition is met, then after that, it will jump to that location. If not, do the next instruction. Okay, so this is the conditions lah that you're going to choose. Okay, that we're going to look at. Okay, there are few conditions that we're going to use. Okay, for the branch with a conditions. Okay, the most apa ni kita panggil commonly used is this one here, BEQ. Okay, branch if equal. Okay, so for the branch equal, it will look at this Z flag. Okay, Z equal to 1. If Z equal to 1, means that the two number is equal. Okay, we already looked at this how to in the previous class. Okay, if not mistaken. Okay, how the apa ni equal, how to determine the equal. Okay, by looking at the Z flag. Okay, next is the B and E. Okay, the B and E is for branch not equal. Okay, so every time the number is not equal, okay, so it will branch to the target location. And for the not equal, okay, we're going to look at the Z flag as well, but the Z flag is equal to 0. Okay, whenever the Z equal to 0, we know that both number are not equal. Okay, and then this one here, BMI and BPL. Okay, so this one, if you're going to check lah, whether the two number is a negative number or positive number. Okay, you can use the BMI or BPL. Okay, the BMI stand for branch if minus. BPL is a branch if plus. Okay, the what we call here, the flex that you're going to look at is a N flex, because the N flex will determine whether your number is a negative number or a positive number. If the N equal to 1, okay, we know that it's a negative number. If the N equal to 0, so it's a positive numbers. Okay, then this is the another what we call here, another condition lah that we frequently use. Okay, BH high, BLS. Okay, so this one is for the unsigned lah. Okay, if you have the unsigned number, okay, we can use this okay to check if whether the unsigned number is higher or lower. Or sometimes we can use this one lah for BHS and BLO. Okay, so this is unsigned, higher or same. BLO is unsigned, lower. Okay, this means that okay, every time you're going to do a comparison between the two unsigned number and going to check is it a higher or lower. So you can use the BH high or BLS. Okay, and if the sign number, then you can use the BGE or BLT for the sign greater than or the sign less than. Okay, or BGT and BLE. Okay, the GT is a sign greater than, LE is a sign less than or equal. Okay, so to conclude that, this is for the sign number lah. Okay, and this is for sign. Okay, if you put the BAL, means that it's always branch lah. Okay, which is equivalent to B. Okay, contoh lah, I put the BAL lompat. Okay, so it will always lompat branch to this location, lompat, which is equivalent to B lompat. Okay, no need to look at any condition. Okay, so that is the 5 branch instruction that we already learned. Okay, now we are going to look at how to update the flags. Okay, how are you going to update the N, V, Z, C flags, okay, inside of the APSR. So every time you're going to do a branch with a conditions. Okay, to update the flags inside of the APSR, there are a few instructions that you can use, okay, to update the flags. Okay, the first one here, you can use the CMP instruction. Okay, CMP instructions stand for a compare instructions. Okay. So what this CMP instruction do? Okay, it will compare two value, okay, by subtracting the operand 2 from Rn, but not store the result. Means that your operand 2 and your Rn will not change. Okay, the value, the original value will remains. Only APSR will be updated accordingly. Okay, so the condition flags are updated. That is useful for conditional branch instructions. Okay, and this is a syntax lah. CMP Rn operand 2. Okay, so the operation here, what happened? Okay, so value from Rn will be subtract with a value from operand 2. Then after that, okay, the flags updated depending on the result from this subtraction operation. So what happened to your Rn and operand 2? Your Rn and operand 2 will not change. Okay, the value inside of Rn and operand 2 will not change. Okay, after the CMP instruction is executed. Okay, only the flags will be updated accordingly. Okay, so let's look at these examples. Okay, first CMP R0 hashtag 0. So what happened here is, okay, you're going to compare. Your R0 is with 0. So this is what happened lah. R0 minus with 0. Okay, then we look at the second instruction, PEQ 0 level. So on this second instruction, okay, the instruction only jump to the 0 level when R0 equal to 0. Okay, so that's why BEQ. BEQ stand for equal. Okay, if R0 equal to 0, then after that, it will jump to the 0 level. Okay, the location 0 level. If not, if R0 not equal 0, what happen? Okay, it will execute whatever instruction under this BEQ instructions. Okay, if you have instruction under the BEQ instruction, that instruction will be executed. Why? Because R0 is not equal to 0. Okay, if R0 equal to 0, then after that, it will go to the 0 level. What happened? Instruction below of this BEQ, that instruction will never executed. Okay, because you already jumped to this location. Okay, so every time you're going to what we call here use this condition branch, Okay, make sure that you use the CMP instruction. Why? Because we're going to update this flags here. Okay, depending on the condition you're going to choose lah. Okay, so this is another example. Okay, move R0 hashtag 5. So why? Okay, R0 equal to 5. Okay, and then move R1 hashtag 0. 10. So R1 equal to 10. Okay, next, CMP R0 and R1. Okay, so now you're going to compare. Okay, you're going to compare R0 with R1. Okay, so R0 minus with R1. Okay, so this is the operations lah. Okay, when you do the CMP. Okay, when you execute the CMP instructions. Okay, it will compare R0 with R1 by subtract R0 minus R1. Okay, next. Okay, we see here. BGE besar. Okay, what is a BGE? Okay, looking back at this. Okay, the BGE stand for, okay, sign greater than or equal. Okay, if the R1 is greater or equal than, sorry, sorry, if, okay, so this one is a BGE, BGE besar. So what happen? It will check whether R0 is greater or equal R1. Okay, if yes, then it will jump to besar. If not, okay, it will, okay, execute, okay, the instruction under the BGE instructions. So in this case, what happened? Is it jump to besar or not? Based on these examples here. Okay. Jump or not? Anyone?
No, Doctor.
Okay, it will not jump. Why? Because if you can see here, R0 is 5. Okay, and then meanwhile, your R1 is 10. So R0 is smaller than R0 is smaller than R1. Okay, so it will not jump to besar. Okay, in this case, this program here will execute the program under the BGE besar. Okay, so that is the first instruction that you can use to update the APSR. Okay, the second instruction that you can use to update the APSR, the flags, is by using the CMN instructions. Okay, the CMN stand for compare negative. Okay, so what the CMN instruction do? Okay, the CMN instruction compare two value by adding the value of operand 2 to Rn, but does not store the result. Okay, the condition flags are updated. That is useful for the conditional branch instruction. So this is the syntax lah. CMN, Rn, operand 2. Okay, you have two register here. One is the Rn, the first operand, and the second one is a register 2 or operand 2. Okay, so the operation is Rn plus operand 2, and then the flags will be updated accordingly. What happened to your Rn and operand 2? Rn and operand 2, okay, will remain. The value inside of the Rn and operand 2 will remain. Okay, will no change lah. Okay, and this is the examples. Okay, so by looking these examples here, move R2 hashtag 4. So what happened? R2 sama dengan 4. And then CMN R2 hashtag 4. Okay, you're going to compare, you're going to do a compare with a negative. Okay, the CMN. Okay, compare negative R2 with 4. So what happened? So R2 plus with 4. And then next, PEQ. Okay, PEQ stand for branch if the result is equal. Equal means that it produces 0. Okay, so if we look at this one here, okay, on the operation of the CMN says that R2 plus 4, so what happen? It will produce 8 lah. And when it produce 8, means that Z equal to 0. When Z equal to 0, it is a not equal. So it will never go to this target lah, to this location. Okay, the result is 0. Okay, and moving on to the third instruction. Okay, to update the what you call the flags inside of the APSR. Okay, we can use the TST instruction. Okay, the TST stand for a test instructions, and these instructions perform a bitwise AND between two operands and update the condition flags. Okay, means that by using the TST, okay, it will do a logical AND. Okay, between the first operand and the second operand. Okay, so this is the syntax: TST Rn operand 2, and the operation here is do logical AND between Rn with operand 2. Then the flag that updated only Z and N flags. Okay, C and overflow flag will never change. Okay, the flag will remain. Only Z and N flags will be updated accordingly. Okay, contoh. Move R0 OXFF. So sekarang ni R0 equal to FF. Then after that, okay, TST R0 with hashtag 01. So what happened? Okay, you're going to do a logical AND lah between R0. R0 is 1, 1, 1, 1. Okay, every time you do a logical, okay, I advise you to change it to binary number. Okay, 01 is a 0, 0, 0, 0, 0, 0, 0, 1. Then do a logical AND. So 1, 0, 0, 0, 0, 0, 0, 0. So what happened? Now the N equal to 0. Why? Sign B is 0. So N equal to 0. What about your Z flag? Z flag also 0. How is that? How you get the Z flag is 0? Because the result produce a value. Okay. Now this is the flags lah that updated. Okay, after you do the TST instructions. Then moving on to the next instruction, PEQ bit 1 clear. Okay, PEQ stands for branch equal. Branch equal means that Z equal to 1. Okay, every time the Z equal to 1, it will branch. Okay, so here, since Z is from the TST instruction just now, the Z value is a 0. So what happened? Okay, the CPU will execute instruction under the PEQ instruction. Okay, the bit clear location will, okay, this bit one clear instruction will never execute. Okay, why? Because Z equal to 0. If the Z equal to 1, then after that, okay, it will jump to this bit one clear location. Okay, next instruction is a TEQ instructions. Okay, the TEQ instruction is for test equivalence. Right, so what this test equivalent do? Okay, it perform a bitwise exclusive OR. Okay, TST, exclusive, logical and TEQ is a bitwise exclusive OR. Okay, between two operands and update the conditioned facts. Okay, so the syntax is TEQ RN operand 2, and this is the operation. Do a load exclusive OR between Rn and operand 2. And what are the flags that will be updated? On the Z and N flags. Okay, so this is examples lah. Okay, move R0 hashtags F0. So R0 equal to F0. And then move R1 hashtag 0F. So R1 equal to 0F. And then TEQ R0 R1. Okay, what happened when TEQ? TEQ means that you're going to do a exclusive OR. Okay, so now what happened? You're going to change lah from hexadecimal to binary. So F0 is 1111 0000. 0F is a 0000 and 1110. And then you need to know lah what we call here truth table for exclusive OR. A, B, F, 0001, 10, and 11. Okay. If you don't know how to derive the truth table, okay, you need to know the equations lah. Okay, of the exclusive OR. Okay, if you forgot the truth table for exclusive OR, you can derive it from the Boolean expression of exclusive OR. So exclusive OR is A exclusive OR B equal to A bar B plus A B bar. Okay, and then just take random input here. Let's say like 1 0. Okay, I put 1 bar 0 plus with 1 0 bar. Okay, so bar is a not lah. So it will become 0 0 plus 1 1. Okay, 0 and end with 0 you get 0 lah. Plus with 1 and with 1 you get 1, and the result will produce 1. So now you know lah. Okay, the value will be 0 0 1 1 0. Okay, and based on this truth table, okay, now you're going to identify lah. Okay, what is the output after you do the TEQ instructions? Okay, the result will be, okay, so since this one 0 1 will produce 0 0 1 is a 1 1 1 1 1 1 1. So the final output is FF. Okay, so now you look at this instruction, B equal case. Okay, so every time you see the equal means that we're going to look at the Z flag. Either the Z flag, okay, the Z flag should be 1 lah. Okay, and for this case here, Z flag is 0. So what happened? Okay, the jump will never happen. Okay, it will not jump from this location to the equal case. Okay, not jump. Okay, why? Because Z equal to 0. If Z equal to 1, then after that, okay, it will jump to this location. Okay, any question up until here? Okay, if no question, then we move on to this, okay, the fifth instruction, how to update the APSR. Okay, so to update the APSR, okay, instead of using the TST, TEQ, okay, and then compare, okay, we can use the suffix S. Okay, what is a suffix S? Means that at the end of the instruction, you're going to put the S, okay, the suffix X at the end of the instructions. Okay, by adding the suffix S to the instructions, mean that the instruction will update the condition flags. Okay, so every time you put the S at the end of your instructions, okay, it will automatically update the APSR. Okay, these flags are crucial for the condition execution and branchings. Okay, the syntax, contoh lah. Okay, ADDS. Okay, so after you do the addition of this operand here, then the APSR will be updated accordingly. Or SUBS. Okay, so every time you put the S after the sub instructions, then after that the APSR will be updated. Or okay, you're going to do a logical AND, then you're going to update the what we call here, update the flags, okay, at the same time. So you can use the A and D followed by S. Okay, after you do a logical AND, then after that the APSR will be updated accordingly. Okay, contoh lah. We have the contoh here. Move R3 hashtag 20. So what happened? R3 equal to 20. And then move R4 with 20. Okay. Lepas tu, subs R5, R3, R4. So R5 sama dengan R3 minus R4. Okay, so 20 minus 20 lah. Okay, then after that, okay, we see branch not equal. Okay, branch not equal, it will branch to this location, label not equal. Okay, means that if the result is not 0, okay, because not equal is, we're going to look at the Z flag lah. If the Z flag is 0, okay, so it will branch to the not equal. If the Z equal to 1, so it will not branch to this location not equal. Okay, so this is another way lah, okay, to what we call here, to update the suffix. Sorry, to update the APSR by putting a suffix S at the end. Okay, at the instructions. Okay, let's say like I'm not going to use the suffix S. So what happened here? Okay, I'm going to use a compare. Instead of put the suffix S at the SUB, now I'm going to do a use a CMP. Can I do that? Yes, but I need to add an extra lines lah. Okay, so here in between, right before the BNE instructions, I need to use the CMP R3 with R4. Okay, so add another instruction in between sub and BNE. Then after that, okay, it will compare between R3 and R4. Okay, so if R3 and R4 produce 0, it will do the following. instruction under the P and E instruction. Okay, if the R3 and R4 produce value, so means that the both number is not equal, so it will jump to this location. Okay, any question up until here? Okay, before we go to the flow control.